In example 12.3, we are asked to use the graph below to determine the function's equation, not a full function definition, just the equation, in both vertex and in standard form. Let's review what these forms look like. Vertex form is y equals a times x minus h squared plus k. And for standard form, we have y equals ax squared plus bx plus c. Let's look at the graph. From the graph, there are several things that we can glean about some of these values that we're going to need. For the vertex form, we're going to need to know what's the value of a, what's the value of h, and what's the value of k, if we're planning on being able to write that equation. For standard form, we need to know a, which will be the same as the a for vertex form, but then we would also need to know what's the value of b and what is the value of c. So what can we get from the graph? First thing I can get is the vertex. The vertex, I can clearly see, is located at -2, +3. That tells me that h is -2 and k is +3. So we immediately start making headway on the vertex form. We can also notice that this parabola is opening down. So the fact that this opens down tells me a few things. It tells me, number one, that it's going to have to be a negative. Now I put -1 there, but it may not necessarily be -1. It could be potentially something else. Then I have to look at the way that the curve is shaped. So from the vertex, notice that I go over 1, down 1, and then back to the vertex I go over 2, down 4, which is the basic parent function shape, just opening down. So that does verify that it should be -1 and not -2, -3, -1/2. There is no stretch or shrink happening here. So we can say that a would just have to be -1. Take a, h, and k and then plug them into the equation. It's going to say y equals -1 times x minus -2 squared plus 3. Now inside the parentheses, we do have this x minus -2. We don't typically want to leave an algebraic expression with subtraction of a negative, and we oftentimes don't leave a multiplier of -1 written in the way that it is here either. So this is going to be the cleaner version of the way that I want this written. You'll just put a negative symbol, open parenthesis, x plus 2 squared, and then plus 3. And that is going to be the equation for the vertex form of this function. Now, for standard form, the only thing that I can reuse from the vertex form is the value of a, -1. The value for b and the value for c are difficult to be able to grab directly off of the picture of the graph. So we're not even going to try. So instead, what we are going to do is we are going to expand the vertex form. So to expand the vertex form means that we need to go through the order of operations that are there. The first operation that I need to deal with is the exponent. The exponent implies that I should have repeated multiplication of x plus 2. Specifically, it should be there twice, x plus 2 times x plus 2. When I perform the distributions on that, I'll end up with x squared plus 4x plus 4. And all of that stays in parentheses because the result of that squaring has to be multiplied then by -1 before you can add 3 to it. Think about order of operations. Now I would write y equals negative x squared minus 4x minus 4 plus 3. And then finally y equals negative x squared minus 4x minus 1. And that gives me the standard form version of the exact same function. Same function, just 2 different ways of writing the equation. And it also shows that a is negative 1, b is negative 4, and then c would also be negative 1.